Good afternoon, everyone. I invite you all for the session one of day three, the activity of Agentic AI. I welcome Dr. Nikunj Tahil Ramani for the first session of the day. Dr. Nikunj, are you there?
Okay, so I think we can start.
Yes, sir. You can start.
Yeah. Okay, so good afternoon to everyone. So today we will continue the flow from where we actually started. So I am just putting my GitHub link uh, without any kind of delay so that you can start at your end also. Yeah, so I kept one GitHub link. I'll share my screen. So what you need to do is I'll just let you know that what you need to do in case of so there are many ways with which you can do this. So first I'll just write down the ways, which are the ways. So those who are having the VS Code ready and Python is already installed inside it, then what you can do is you can follow the steps of cloning of my GitHub repository. Okay, so I am just pasting the procedure so that you can just. So first of all, what you need to do is you have to install the Git. If you don't have Git, then first install the Git. Okay, and then you can just apply this command in your PowerShell. So you can do it in PowerShell or you can do it in command prompt. If you are using Windows system, this is the procedure. Because I am having the Windows system, I am keeping that. The first way is first you have to install VS Code, then you have to install Python. Then that Python, whenever you install, you have to just tick mark, add that python.exe into the path so that VS Code will be able to discover your Python. Then when you open the VS Code, there is an extension on the left hand side bar. There you write Python and install the Python so that you will be able to run all the Python codes which will be we are going to run in this session also. Okay, so this is the procedure. Step number one, you should have VS Code, you should have a Python with you. Once you have that, you have to install Git because I will share the screen. I have stopped my screen for now. I will share the screen. Don't worry. I'm just writing down some instruction and then I'll share. So once you install the Git like this, then you can just clone my repository. This is what you can do. I hope my voice is audible properly, and I'll share the screen. I'll let you know when I will share the screen. And those who don't have this, uh, don't want to go inside that GitHub and Git wala part, like you don't have a Git in, or you don't want to install the Git, only you have a VS Code and Python, then you can directly go for processing of creating a folder. So now I will share the screen, so I'll directly tell you that procedure. Those who don't want to go for this Git part. Okay. So what you can do is you can just go on this starter, which is the first folder which we are going to explore. Go into that starter, and in that starter you will get these codes. Okay. So what you can do is just go to this one by one. The flow is there. So we will start with this flow, the first number BMI workflow. Go to this and download this file from this, download the raw file. Now you can make any folder in your drive. Supposedly the new folder you create, you give the name code and put that downloaded thing over here, that file which you have downloaded, which is BMI workflow over here. And then directly you can open the VS Code from the PowerShell, or directly you can open the VS Code and select that folder. So supposedly if you want to install in E drive, you have made the folder in E drive, right? In that you will get all the directory. There you will find your one folder. Go to that folder, let's say folder is code, inside which you will get that Python file which you have downloaded from the repository and you kept inside this, and then you can directly write code dot and press enter. So once you write code dot, your VS Code will get open in this folder directly. Okay, this I am doing in PowerShell. You can also do it in command prompt. Make sure your VS Code and Python both are properly installed so that you can run the flow. So this is what is the procedure for installation. Now the next thing is uh, how to run. So what this whole structure is all about. This is for, yeah, I will repeat just for a time being. Give me some time. I will do the repetition. Okay. So what we need to do in this case is how to run these codes. Okay. So simply again one more time, you download my file. If you don't want to involve in the case of Git and all those, you don't want to install Git and then Git clone, just download this file, make one folder in your any of the drive. Let's say the folder is code. Put that file over here and directly open the VS Code. Open the VS Code, and in VS Code, here you will get the option in file open folder. In open folder, there will be one folder which you have created just now. Here you will find my Jupyter notebook, which you have downloaded. Okay, so you just open that. Okay, so you can run both IPython file and Jupyter notebook IPYNB file and .py file. There is a difference between these two that I will tell you for after some time. Let's come to the topic itself. So that is the first part. Second is when you have this kind of thing ready over here on the left hand side panel. Supposedly you have the first thing which is BMI workflow. Then you go to my GitHub repository. Keep this repository open in one of the your tab. In starters, there is one file called as readme. Go to that readme file. Here I have listed all the procedure that you need to start from the beginning. Let's say the thing which I told you, you have to first clone. Okay, and then go to that folder. So here you will be getting that folder directly. So currently my folder is NIT Jaipur codes. Here I am having all these code base. This is my code base. So this is the starter folder in which currently I am right now. Okay. So once you see your file over here, once you are in this path, which is your folder path, then the next procedure is You have to activate the environment. You have to make the environment. Now, what is that environment? So the environment is like this, that supposedly this is your folder. This is your folder, which folder name is code. This folder name is code. Okay. Now in this code, you have to first create virtual environment, which is VENV. I have already pasted in the chat box. Please see the chat box. VENV. What do you mean by this virtual environment? Virtual environment means what? That whatever now you will be able to execute, that all things will be inside this virtual environment. Okay. So what we need to do first is, first we have to create this virtual environment. It is like a platform in which you are going to run your all codes, inputting your all the datas, everything, your APIs. Okay. So the folder requires the virtual environment, and for that you have to create the virtual environment. So if you see my this screen here, you have this virtual environment which is having a name my env. Okay. Now how to create this? First is follow this procedure. Take this command, copy it, and paste it over here, and press the enter. So what do you mean by this? This is nothing but creation of virtual environment. It is a creation of virtual environment, and the name of virtual environment is my env. The name of the virtual environment is my env. Here you can give any name. You can also write auto env or whatever name you want to write. Okay. So this is the customized name which you can give. So once you run this command, it will create this virtual environment for you. Okay, this environment will get created. Now inside this virtual environment, you have to install all the dependency. Dependency means what? Dependency means all the required library which are there to run your Python codes. Okay. Now where are those libraries? Okay. So those libraries, what we are going to do is, whatever libraries are involved to run the code, that we will put inside something called as requirement.txt. Requirements.txt. This is the txt file, text file. Where this is in my folder, it is there over here. So how to do this? How to create this? Just click on your starters, this folder name, and press this new file. Okay. So when you click on this, you will be able to get the file, and you can name that file with the extension of the same. .txt, .ipynb, .py, everything, whatever you want. Okay, right? So just click on this, and just click on this, and whatever file you want to make, you can make in that. Okay. So if you see my requirement.txt, here I am having all the required libraries which are required to run my code, because I am going to import many functionalities out of this library. I will be using many functionality, many modules of this library, which is required to run my code. What I suggest is, please look at over here for a time being. Don't do it currently. Just look at the procedure, understand the procedure. You have the recording of this session. You can do it after the today's completion of my class. You can do it at your own, and you will get the idea that how to do it. Okay. So just follow the procedure, that just look at the procedure, listen the procedure, that how I am, uh, how to install this whole thing, and how to run the Python codes inside the VS Code. Okay, right? So don't do it right now, because then it will create a chaos, and then you will get the error, then you will be having a confusion, then again there will be a the time which I have to give into that, right? So don't do that. We have to also cover the content. So uh, from my side, the sound is perfectly fine. Uh, the others can just let me know, because from my side it is okay. So once you do this, then uh, you can just go inside your my GitHub repository, and in GitHub repository in starter folder you will get this requirement.txt. So those who are just downloading it from my GitHub, just click on this and directly download the raw file. Put that file directly into the folder, whichever folder you have created, like my folder is starter. The same procedure you have to repeat for all the Python codes. Okay, just put it inside. Okay. Now, once you have made this requirement.txt, once you have made the virtual environment, now you have to install these requirements. You have to install these requirements inside this virtual environment. You have to install this requirement.txt inside this virtual environment. Okay, this is very simple procedure, that whatever dependencies are being used in your code, you have to install inside the virtual environment, because virtual environment is the environment from where we are going to run our code, we are going to run our dependency, we are going to run whatever file which we have. Okay, so for a time being, this is your virtual environment, which is there inside your folder, and inside which you have to create requirement, you have to install requirement.txt, right? Okay. So before installing this, once you create the virtual environment, you have to activate this virtual environment. Activate. Activate means you have to now perform the task inside this virtual environment. So you have to trigger this. You have to keep it on. Okay. And for which the command is what? For which the command I have already listed over here, which is this one. This is the command to activate the virtual environment. So once you copy this and paste it over here and press the enter, then what you will get is you will get something like this. Your virtual environment is activated. From where to get this screen? This is a terminal. You can get it from view. This is a terminal. Okay, so here you have many options. You have Git Bash, you have PowerShell, you have uh, terminal, command prompt, whatever you want to like. Your choice. You can just put it over there. Okay, you can use that. I generally use the command prompt, so I am doing inside that only. So once you do that, your virtual environment will get activated, and then once your virtual environment, which is your activated virtual environment, you can install your requirement.txt, this particular text file. For that, again go to my repository, and in this you will find this command, which is pip install requirement-r requirement.txt. Pip install -r requirement.txt. Right. So once you do this and press the enter, okay. So what will happen is all the dependencies, you can see all the dependencies are getting installed. Which dependencies are getting installed? Whatever dependencies are there in this file requirement, which will get installed. So once you do this, your requirements are installed. Now you have a ready to go license to run all your Python codes, or maybe IPynb file. Now many of the folks are having confusion that why IPynb not .py, or not why not .py, why IPynb, right? So IPynb file which we use whenever we make this file, basically these files are used for experimentation stage, when we are going for production ready deployment of the projects like LangChain and LangGraph, Crew AI. These are the frameworks which are only used for deployment of production grade ready applications of agentic AI. Okay, so once you have this kind of thing, which is IP by NB, whenever you perform any kind of data ingestion, like you give the data as an input, whatever your data is, speech, text, whatever, image, and then you test your AI model in this using IP by NB. Once your IPYNB is running fine, you can just monitor that through some ML flow kind of software, right? And in that case, what will happen is you are able to get the functionality of your code. Once it is running file, then you can just go to the .py, generate the .py for the same code. It will make a pickle file, and then you can go on further for making a Flask-based API or and then deploy it on the cloud. Okay, so IPYNB is the preferred file when you just explore the things from the initial stage. You test your application at the staging part. Staging is one of the part when we go for a production ready deployment in ML ops or LLM ops or AI ops, which is agentic AI ops. Okay, so these all ops are requiring LangChain, LangGraph, Crew, AutoGen. That's it. Okay, so you have to do everything in this uh, over here only. Okay, so now I hope the things as a part of installation is clear. Now I will go to the first workflow. Okay, before that, again, you can click on this starter and click on this new and make a .env file. .env file is like this. This where you can just write down your API keys, which I explained you yesterday that how you can get. Okay, don't use my grok API key. You can just write down like this and then paste it over here. So how to write grok API key equal to, and then it's a part of string. That's how you are going to write it. Okay. So now this is the first workflow that I wanted to explain, which I actually started yesterday. So I will first explain that and then I will move to next. So what is the way out? Like how to uh, understand the line graph very effectively, or what are the steps which you follow, then there will not be any kind of confusion working with the line graph. Okay, so the first part is that you have to decide what is your objective. What is your objective? Objective is what? Calculation of BMI. Calculation of BMI. Okay, now what will happen is that for BMI, what you need, right? So you need weight, you need height, right? Both of them will be combined with some kind of formula. There will be one formula which will give you a BMI. So currently, you have to decide first what are your input variables and what are your output variables. You require weight as an input, you require height as an input, you require BMIs as an output. So in your graph, you have to include all these things. Now, how you will be able to include? You have something called as, yesterday I explained you, state. Okay. State will be carrying all these variables. Why? Because state is the message passing entity between the nodes. Okay. Right. You have a nodes. There is a next node. There will be a message passing, and that message passing through there will be a state. Okay. So you have to first design in your mind that what will be my state variables. Once you have that, then it will become very easy for you to write down the individual functions for the same. write down the individual functions for the same. Okay. So now, if I want to draw the graph for this, sorry, how this graph will look like, how this graph will look like. So the graph will look like this, that there will be a start, there will be a start, so that will be entry node. Okay, that will be a entry node. Okay, there will be this entry node, or start node. Then next is what? Next is your calculation of BMI, and then there will be end. This is my simplest graph. Entry, that is a start, then calculation of BMI, and then there will be an end. Okay, so this is the only simple graph you have to draw and compile inside the line graph, and that every node which I discussed yesterday is nothing but a Python function. Every node is nothing but the Python function. Every message passing is nothing but the state passing. So these are the things which you have to remember without fail. Okay, right? So now let me go to my workflow and explain you. So what is the first step? First step is, I told you, LangChain documentation that you have to clearly follow. Okay. Again, I am showing you lang graph, sorry, lang graph or LangChain, whatever docs are there. Okay. Go to this and you will get all the details. Okay. So you will get all the details from this, and just go to each and every particular tab, whichever you require, and study from that. So first is I need to plot the graph. The graph is the type of the graph is state graph. Why? Because we are going to use state for passing the messages between the nodes. There will be a start, there will be an end. Okay, right? Now message passing is always through type dict, which we discussed yesterday. Why we need the type dict? Because we want a structured output from the model. Okay, and this message passing is always through structured output. From one node to the other node, there will be a structured output, answers will get passed, right? Because see, weight is one variable having some number, height is having some number, BMIs will be your output. So this is how you have to create the state. You can name the state as per your convenience, whatever you want, and this should be inheriting type dict. It's like a child is following the parent. BMI state is following the parent, which is a type dict class. Okay. Inside which we have to define all the input and output which we are going to work with in our workflow. So weight is one number, height is one number, BMI is the output. Okay. Now let's draw the graph first, and then we will write the function. Okay. So that it will get more clear. Now, how to draw the graph? Take the variable graph. What is the type of that graph? State graph. And for which we are going to plot? We are going to plot for BMI state, because this is the state which is going to get passed between the nodes. Okay, so this is the BMI state which we have to write it over here. So the same thing. This is a BMI state. You just have to write it over here. Okay, so now your graph structure is blank. Now you have an entity, right? Like in MATLAB, if you have used that, you have a figure. Once you write down the figure is created. Now you have to add the plots and subplots. Same way, once you do this, your graph object is ready. Now you have to add the nodes and connect those nodes one by one. Okay. So first we have to add the nodes, and then connection will take place. So the first node is calculate the BMI. I'm naming that node as, should I increase font size? Okay. Is it okay now? I have increased the font size. If you, yeah, okay. So first node is calculate BMI, which is nothing but the function which I am going to write. So here there is a name which you want to give to that node, and this is a Python function that you have to define. So it will directly go to that function. Okay, this is a function and this is the name of that node. This is how you have to create the node. Okay, I this node is clear. Okay, for a time being, you can just ignore this label. Label means what I am doing actually is that once you get the BMI, I am deciding the category, whether that person lies in a obese category, whether that person is lying in the category of fit, whether that person is lying in the category of excellently fit. The category I have made based on the BMI number. Okay, right. So that also I have included in my graph. So you can add this also. So you can add the functionalities from your side, whatever you want to include. Okay. Now, once you are able to create the nodes, now you have to connect the nodes. How you'll be able to connect the nodes? You have something called as initially for adding the node, you have a add node. For connecting the nodes, you have add edge functionality. From where it will come? It will come from the graph, which is nothing but inheriting the BMI state graph object. Okay, so this is a class and this is a object. It's like a state graph is nothing but the way which we define all the variables. Okay. Now you have to connect the edge. How you will be able to connect the edge? First node is always start. Why? Because I have already given over here start. Then next is, which is my next appropriate node that should come? Directly calculate the BMI, because this is the function that I am going to call, and I have already defined this node over here. Okay. Now, after calculation of BMI, I am also finding out the category of the person, in which category it belongs. Let's say that also function I am writing. So for that, I have taken one more node, which is label BMI. So I will also include that. So my workflow will also find out in which category the person belongs. Okay. And that is the last node. And after that, from label BMI, it will go to the end. This is the flow of your graph. Just simply write from where to start, where to stop. Then next from where to start, where to stop. Then from next from where to start and where it will get end. After this, you cannot add anything in the graph. Okay. Now, once you do this, then the next step is compiling of that graph. Because you have made the graph, but you need to compile all this graph. Because before I'll do that. I'll explain that function itself. Just look at the graph, how to make the graph. I'll come to all these things. What are calculate BMI, label BM, and all this. So compile the graph. Compile the graph means find out whether the whole graph is connected properly. Is there any misconfigurations are there in the graph? If it is there, if there is any break in the graph, if any node is not working, like if the node is having some Python function but it is not performing properly, then it will not invoke the graph. So it will compile that graph. Okay. So generally, for a time being, you understand that if the nodes are connected properly or not in the graph, that is the only point in the case of compile. Okay. Now, once you define this, this is the way you prove the land graph. That's what the exact flow I'm telling you. Once your this boilerplate code is ready, boilerplate code means this is a code where you don't have to do that much of technical jargon. You should know what are the nodes that you need to define, what will be start, what will be end. That's it. Okay. Once you have this, now you have a clear cut idea that what will I need to write the function which is calculate BMI. I need to write the function label BMI. These two functions I need to write. So directly now go to the write the first function which is calculate BMI. Now those who are not aware about the Python, they have to know the Python for learning agentic AI and Gen AI, because you have the different data structures for storing the data types or datas. There are different data types like set, tuple, list, right? You should know about OOPS concept, which is the class concept, and you should also know about how to do the logging and exception, which is which is used for real time production grade deployment of the agentic AI apps. So currently we don't have to look at the logging and exception or file handling. Okay. So calculate BMI. Now see the function. This is a way of defining the function in Python. Okay. So this is the keyword. Calculate BMI is my function. Now what I need to pass to this function? Since I am doing the message passing through state only, I can directly give the whole state to this function, which is calculate BMI. This is my input to the calculate BMI function, which is a state itself. Inside state, you have three variables: weight, height, BMI, and also the category, which is the last one. Okay. Now, what this function will give you the output? So, what this function will do? It will calculate the BMI. Okay. And then it will update the state values wherever it is required. Supposedly, there is no need to update the weight. There is no need to update the height because these are your input. But what is to be updated? BMI, because BMI is not having any value currently. Without running the code, BMI is null. It does not have any value. So once it will run this, it will also return the state itself, and in which you have the BMI value directly appended. Calculated BMI value will be see over here. Okay. So this is the way of defining the function, which is now this is a node. I told you node is a Python function. This is how we have defined the function. Okay. All these comments are already there in my GitHub repository. So you can just go. I have written like you understand it. It's like a very beginner level understanding is as a part of comments are being written. So just look at those comments. You will get the idea that what this code is actually doing. Now, what you need to do is you have to take two input values. One is weight and one is height. How to give the values of input? I'll tell you. But understand that I am having a value of weight. I am having the value of height. Okay. Now, how I need to fetch this weight value? How I need to fetch? I need to fetch it from the state itself because my message passing unit is state. So everywhere I need to consider the state. Whenever I pass to the function, that also state. When I fetch the particular variable from the state, there also you need to define the state. State of, this is called a state of, and then this is the weight value, put it inside the weight. Take the height value, put it inside the height. So you have weight and height ready with you inside this function, which is called as calculate BMI. Now apply the simple formula. BMI equal to B divided by any formula, whatever formula it is. Okay, this is just a random formula which I found that I kept it over here. Then you have the value of BMI. Now what you need to do, you have to update the state which is being passed to the calculate BMI. So what you need to do, again, state of BMI equal to whatever value you have. We don't pass generally the supposedly the float value. Here also I have defined float, but I am rounding it off. There are rounding that are ceiling operation. So you just round it off so that uh, that value will be rounded to the particular integer, and that integer you are going to update in this state, which is having a name called as variable name is BMI. Okay. And then the answer, which is a, what is the answer? Answer is BMI state. So what you need to do? Return state itself. Instead of specific variable called as BMI, don't return the variable BMI, return the whole state altogether. Okay. So the main crux of this function is it will get the state as an input. It will return the state as an output, inside which fetch the variable from the state, calculate the values whichever you want, apply the logic, the heart of the whole program, apply it in the function. Whatever answer is there, you have already defined that variable in the state. Just update that and return the whole state. Okay. So now my state value is having a BMI calculated already. Now, what is the next category in the graph node? The next category is label BMI. Label BMI. So answer of calculation of BMI will go to label BMI. So because label BMI wants the value of BMI value, so that will obviously come next after the calculate BMI. So in label BMI, again, see the way of defining the label BMI function. It will take the state as an input, return the state as an output. Now we have already calculated BMI, just fetch that and put it in some local variable, create any local variable and apply the logic, the heart of the uh, categories. Yeah. So if BMI is less than 18.5, the category is underweight. Now this is again your own will. Whatever you want to do, you can just put it like that. Then 18.5 to 25, normal. 25 to 30, overweight. And else it is obese. This is what I made. You can do it according to yourself. Okay, right? So you have two functions ready. One is calculate BMI. The second is label BMI, right? Now you have already draw the graph. The graph I'm taking it inside workflow. So what you can do is you can compile this workflow and you will get it like this. When you draw the graph, you have to draw the graph like this. You have to use something called as mermaid. If you want to get the image, you can do this. Otherwise, you can simply write workflow and run this. You will get this graph directly. If you want to get this graph in the form of image, then you can use this mermaid PNG. Maybe many of you are aware about this mermaid. Maybe you are getting the help of mermaid to draw the complex structure, mind maps, and all those things, right? So you're this is where you compile and okay. Now how to give the input? So input is given like this. Initial state. This is the variable. You define the variable. Now this state is nothing but the type bit. Type bit is nothing but key and value. So always give the input in terms of key and value. Always give the input in terms of key and value. Again, type dict is dictionary only. The only feature it is giving that it is data validation also. It is having implicit data validation, data typecastings, right? I don't remember that word, not typecasting, but it is uh, inherent changing of the type. I'll tell you. I'm not able to remember that word. But yeah, it is able to validate your data like float, integer, everything. You just define it over here. Your collaborator will be able to know what are the inputs. Okay. So that how it will be able to do that. So initial state, my first variable of the state is weight. The value is 90. Second variable is height. Value is 1.73. This is how you have to first give the input variable in the form of key and value. Again, for giving this, you have to again go back and find out this. What is this? What are these variables? The same variable you have to copy and paste and then provide the value. Now, how to run this graph? We made the graph, but how to run this graph? So for that, there is one function called as invoke. There is one function called as invoke. Like in when we run the model, we have model.invoke. When we run the grok model, chat gpt, we are using model.invoke. Model is nothing but any model which you define. Same way workflow.invoke. What you need to pass? This you have to pass initial state. Why you are able to do this with invoke? Because it is a runnable object. Runnable means in LangChain everything is runnable. The chain, whatever the LangChain funda is, that everything is in sequence. That is a runnable sequence. So that is a runnable object. That is why you are able to do this. But don't go into that right now. Just understand. Invoke means executing the graph, triggering the graph, so that the whole workflow will get executed one by one, node by node. Okay, it's a very general name, invoke. Once you hover over your mouse, it will give you everything like what this is all about. Okay, so uh, that's how you can give the input, right? So what you can do is, once you have your code ready, then you have to select this Python kernel. So once you have installed this virtual environment, it will be asked, it will be asking you that which Python version you want to get it into. So you just have to select the Python version, Python 3.13.5, and that this is the latest version which we have. Okay, so just select that so that it will be able to run your whole code inside this Python version. Okay, again, how to install Python? You have to install it from the python.org, and then here you have to search for the package. Here you have to search for the package. Okay, so that's where you are able to find the Python. Okay, there are many things that you'll be able to do. Let's say if I write Python, okay, so if it is there, it will be telling me. If it is not there, see, all these Python will be there. Yeah, you can use Jupyter Notebook. Uh, that is altogether, it will be opening in that local host, and you can do with the Anaconda also. That is also fine. But what I suggest, that use any client, because when you go for a production grade application making, you have to have one code editor with you, which is, let's say, VS Code or Cursor. These all offers you some kind of even extra functionality. Like, say, if I want to draw this, I'm using this free draw. You can have some vibe coding options also. Okay, that also GitHub Copilot. You can just go in this extension package and find out GitHub Copilot. Okay, so I have not I have already these things in my this uh, Docker is there. Okay, everything is there. Whatever you want, you just install and use it functionality. So why to go for that Jupyter notebook? Now you come out of the local execution. Now you have to think for production grade ready application making. Okay, and for that you should have all these things ready with you. Okay, so what you need to do is you have to select this and then run cell by cell. Okay, so first time whenever you run, it will try to uh, you have already installed that requirement.txt. Okay, so directly it will fetch your modules from that. So this code is run. Now you run this state again. Those who are not aware about oops, you have to create the class, as simple as that. Name that class. Class is nothing but the parent, right? The parent will be, you have to write the parent with this format, which is a type dict. Type dict is what? Key and value. That's it. Because LLM message passing is always through, or agent message passing is always through structured output, which we discussed yesterday. Okay, so make a parent, name that parent, define all the variables inside that parent, and then directly write the graph, draw the graph, make the flow. Once you have the flow, then write down the individual function. So I'm running this state. Okay, then you can run it individually. You don't have any, like, after this should come, you have these functions run, functions are executed. So now you can directly go to the graph, run the graph, workflow. Okay, so see, I told you that just you write down the workflow, it will give you the workflow. If you want to get it inside the image, then you can just write this mermaid part. Okay, but don't no need to do this. Then execute the graph. So it will execute the graph, and this is what is the values that you are getting. Category is obese. Okay, so this is how you can run this first code which I shown you, right? Now this does not involve any kind of LLM still. This is a simple understanding of what is line graph. This is a simple flow. There is no chat models is actually involved. Just to give you a lineup, I started with this. Okay, now I will go to the taking the model for the question and answer type thing. Okay, chatbot kind of thing. Now again, this library. Now what is this workflow? So the workflow is like this: that I will start the graph. I will ask certain question to my LLM. LLM will give me the answer, and the workflow will get ended. That's it. Simple kind of a reactive chatbot. I'm going with the space one by one. I'm adding the functionality so that you can digest the things one by one. Okay, I will not directly go to the rags and all those things. I'll start with the, because I wanted to show which kind of workflow which we discussed yesterday. We discussed 4 to 5 workflow types in LangGraph. First was prompt chaining or chain of thoughts. Prompt chaining means what? One by one the components will get added, one by one node is there, and the output is sequential output. So we are looking at the sequential output. Then I will go to the parallel workflow, conditional workflow, and I will add the complexity one by one. So currently we are looking at the simple sequencing of the workflow, which is a chain of sequence. Okay. So then the second part is I am going to use Grok. Okay, so LangChain docs, if you go to LangChain docs, you will get all the functionalities that what LangChain offers you. Again, we are not bypassing the LangChain. You have to remember that. Okay, we are not bypassing the LangChain. So this is the documentation of the LangChain. Okay, so you just go through this documentation, how it looks like. Okay, this is if I go to LangChain dot, I don't know which is the website, langchain.org only. Sorry, langchain.com. So here you have a docs. Okay, the same page you will get. Okay, LangChain Python. So if you go on, click on this, here you will get all the things. How to use models. Always go through this. Don't use vibe coding. Always go with this flow. Understand the flow one by one. Like say how to integrate chat OpenAI model. This is the snippet of the code which gives you the idea about how to use the OpenAI model, right? So you just have to go one by one and see how to use, like how to use Gemini. Okay, how to use Grok. Everything is written over here. Understand from this. Take this as your Bhagavad Gita for learning Gen AI and Agentic AI. Okay. So this is a Grok. I am going to use Grok. So it is from langchain.grok, and I have already defined in requirement.txt. You can see this. Okay. So that is the langchain Grok. Again, type dict is required, obviously. This is what I wanted to use now because my API keys are there in .env. Okay. If I want to load that key over here in my main file, I need to use something called as .env, which is a .env. .env I have already defined over here. Means if you want to load your keys from .env to your main file, you have to use this module called as .env, and from that you can use import this sub module called as load.env. So what it will do, it will keep this env, whatever is inside this env, it will able to load that directly over here. So I'll show you how. Once you run this node, so it will run that node. Then you are going to write load.env. Means what? That if you have anything in .env, supposedly currently I am having API keys. If anything is there in .env, if I run this, it will be able to give me that yes, there is something and the Boolean variable will get hit. It is true. If you don't have anything in .env, it will give you false. Okay, right? So that is how you can check that whether you are able to get your keys inside your main file or not. If you run this, if you get false, your API keys are not inside this main file, you cannot use the model. If you get the answer true, means you are able to load your Grok API keys or Gemini API keys inside your this IPYNB file, means you are able to use those. Okay, right? Now, how to see different type of models in Grok. Like if you want to see that we have many models in the Grok, which one to use, right? This is already executed, so I can now click on this. So it is giving me true. Now, if you want to see that which model Grok is supporting, okay, so you have already have this Grok API key inside this .env. You have to write down the same variable over here. So this is what loading of your API key inside this, and you can just see which kind of models this Grok is actually supporting inside this VS Code, or what kind of model Grok is supporting. That's it. So just run this and you will get all the list. See how many models it is able to support. This is the main question. Like many times, the model actually create the confusions. Okay. Supposedly, if I use this llama model, now this model may be not a good reasoning model. Once I will discuss the React architecture, I will explain you how to make a React agent, because React agent is the foundation of agentic RAG. Okay, so I'll explain you how to make a React agent, but there are the models which are actually having a good reasoning capability. Reasoning capability means who can reason that why this question is having answer like this, which I explained you in the first session, that why this question is having answer like this, why this goal is divided into these sub goals. What is the reasoning of that? What is the proof? What is the evidence? Why is it so? That why answer is always comes with the reasoning. And that is why agentic AI is possible. Every agent is React agent. We have also deep agents, but deep agents is the broader architecture. Currently, whatever we are learning, that is shallow agent architecture. We have some tool, we have some memory, we have some uh, model, and we have a that defines your agent. Okay, right? So you can use any one of this model. What I found, I played with almost all of them. Okay, but what I found is this is better and this is best actually. Quen. Quen is best. Okay. So you can use this model. Okay. So currently I am using Llama. You can use any of the model, whatever you want. You can run this model. So that's how you can import this Grok model. What you have written over here, you have written chat Grok. So now you can use this inside your Python code. So what you can write is chat Grok, define the model, and whatever model you want to use, name that and put it inside the variable model. Okay. Now again the same procedure, creation of the state. So which state you are going to create? Let's name the state as LLM state. Okay. LLM state is the state of my name of my state. Okay. The parent is nothing but following the type dict. Okay. Now how many variables you need? First you have to decide. You have to decide that. What is your job? Typing a prompt, getting the answer. So only two variables, question, answer. What will be the types of this data type? String, string. Your job is done. Defining the state is done. Now this will help you to create the graph and this will help you to create the function. So this is the main part, creation of the state. Okay. Now once you do this, go to creation of graph. Don't write the functions. Don't directly write the functions. Now create the graph. Again, we have to take this LLM state as a state graph object. What is the first step? Add the node. What is the node? I want to have only one node, which is kind of a chatbot. LLM question and answer. This is the name of the node. And what it follows? It follows this Python function. It will directly call this Python function, which I have written it over here. Okay. Now, once you define the node, you have to define the edges. So edges are what? Start to first node, and that node will be the last node. After that, that will be end. Add edge will be the functionality. Okay. Once you do that, what idea will get that I need to make only one function, which is LLMQA. That's it. My job is done. Then you compile the workflow. So that will be compilation. So what I'll do, I'll just run this so I can invoke the graph for you. Okay. So now graph is compiled. Now right after this, immediately next step is no, that is again come, that will be then the spin-off of the multi-agent architecture. That is the different way out. I'll tell you that. LLM QA. Okay. You have to write the LLM QA. So LLM QA is the function. In that, the input is LLM state, output is also, it will return the LLM state. The same thing. Now, what you need to get it inside this function is this function is performing, taking the question, generate the prompt, and giving you the answer. Yeah, state is the name of the state is LLM state. That's it. The name of the state is LLM state. Okay, which is getting passed between the nodes. Now, question from where you will get the question from the input. From the input, the question will come. So you can directly take that question. Again, you have to take that question, fetch that question from the state, and put it inside the question variable. Okay. Then you have to generate the prompt. Still, prompt generation is not happened. Okay. So how to form a prompt? This is a kind of a f-string notation I have written. F-string. There are different ways like prompt template, chat prompt template. These are the popular ways with which you can write down the prompt. I will show you how to do that also. But this is the simplest way, f-string way to form a prompt. Now what I am writing, just see to it. F-string format, answer the following question. And this is the placeholder which I have created. What is this placeholder? Placeholder means whatever input I am having, I can directly pass inside this using this curly braces. Inside this curly braces, I need to define this variable. This is the simplest way to write down the prompt. Okay. Answer the following question, and the question will be put it over here. So whatsoever question which is being passed from the input, it will kept it over here. Okay. Now, once you have a prompt ready, that prompt is to be given to the ChatGPT, Grok, whatever model it is. We have already defined the model. What is the model? Model is already chat grok. So what I'll do, model.invoke. Now with which entity you have to invoke it? You have to invoke it with prompt. You have to invoke it with the prompt. Okay. Prompt is nothing but this one. Now this prompt, when you invoke this whole model with this prompt, the model will generate the answer. Okay. And that answer will be having many messages. Now, which kind of messages it will be having? So here the messages concept will come into the picture. First is human message. I'll explain you this with code also. Human message, which is your prompt. Then second is AI message. That will come in this prompt template, but I am explaining you right now only. Human message and AI message. AI message means system message. Okay. So if I want to fetch specific message, I can just name that and I'll get that message. So I'll tell you the flow, how it is. Because in ChatGPT also, when you give the prompt, you are getting the answer. Now ChatGPT will store this context one by one into its memory by this only. Human message, AI message, human message, AI message. And all this whole streak of the messages having one thread ID, which is your persistence or memory. Thread ID, let's say, equal to 1. Okay, so if I call the thread ID 1, I will get the whole chat conversation of that particular chat history, because chat history is having ID equal to 1. Okay, so here, if I want to get the content only, like the answer of the LLM of the grok which it is returning, I need to write dot content. So I've written the comment to exactly fetch only answer as LLM return many things. What it returns, I told you, it will return human message, it will return AI message, and so on. I am already interested to get the actual answer, which is from the AI message, which is the last answer. Okay. So here I will take that answer, put it inside the state variable, which is already defined inside this LLM state, which is the answer. Okay, right? And return the state. That's it. So that will be creating the function of LLM Q&A, right? Now, how to give the input? Again, initial state as was previous case. Again, question is key, which is again defined from the state, and the value is nothing but your own question. So when you write down this question and then you invoke your workflow is nothing but this graph. This whole thing will go to this function. It will fetch the question. That question will be kept inside this message holder, placeholder, and then there will be a formation of prompt. That prompt will be given to the model. Model will get invoked, and you will get the answer. And it will return that state having the answer updated with the answer of the model. Okay, right? So let me run this now. Initial state. My question is, how far is moon from the earth? So it will give me the answer. Average distance from the earth is this, and this is your answer. Okay, right? So this is your first basic LangChain workflow, sequence chaining workflow, where you have used some model. Okay. Now the next workflow. So I hope the things are going smooth, and if you have any problem, how did the model see? Inside .env we have a API key. That API key will be getting hit and it will get the answer for you. You just have to define two things: what model you want to use, and you have to define that API key. Okay, API key will get you the answer. So you have used this model and you have used the license to use that model. That license is nothing but key, which is the locking and unlocking key, where that key is giving you the access to the model. So you can use that model and it will give you the answer. Okay. Then prompt chaining. Now this is the workflow which I explained you yesterday with N10. If you recall the same workflow, you have a block generation idea where you have initial, first is outline generation of the block, then the blog is being written by the AI agent, that is a writer, and then there is the third block, which is the evaluator. But I kept it very simple: outline generation and the writing the blocks. Okay, so this is the first part. Again, you have to use grok model. I am using grok, you can use whatever you want. uh, Again, reasonings are also important, so you just have to run this trial and error methods. Okay, now let's see the code. So now my state name is block state, and it is using, again, inheriting the type dict. Okay, so Typed is nothing but the structured output. Now you need to understand that what you want to do in your workflow, how you want to generate the blog. You have to give the title, that is having the type of string. You wanted to have the outline. That outline will be stored in this variable, which is outline having a type of string. And at last, you are going to get the final block, which I am putting it inside the content, which is also having a type of string. Simple, as simple as that. Once you do this, go to the graph, make a graph. So what is the first step? Create an object of the graph. Now add the node. Now how many nodes you require in this? So once you start invoking your workflow from the start, then the first node will come, that is creating the outline. Second node will come, which is the creation of a block. So you have added these two nodes. Now you have to join those nodes using the edges. So first is nothing but from start to creation of the outline, from creation of the outline to create the block, and create the block to the end and compile that. So now you are having clear cut idea that how many functions you need to make: creation of the outline and creation of the block. So go to now define this function creating the outline. Again same, it will take input state as block state, output is also the block state. We are doing the state passing. Okay, now user will give the title. That title will come from here. Now let's go to the initial query part. How to give the input? Initial state, title, which I have already defined in my block state class, and my title is Rise of AI in India. This is my title of the block which I wanted to generate. I will invoke my workflow. Now it will get passed to the this graph. Okay, so now it will first run this create outline Python function. So create outline Python function is like this. First, this title has to be fetched. Again, that is from state. Put it inside title. Make a prompt. Again, f string. Generate a detailed outline for a blog on the topic. Then placeholder. Placeholder is what? The title which you are getting from the user. Just pass it over here in the placeholder. Okay. Then invoke the model, and I wanted to have only the answers. For that I am writing dot content, right? If you want to see the functionality of VS Code, then it will be you can just write down the comments, and many of the times what will happen is if you have GitHub Copilot or that is installed, it will give you the comment directly. Okay, so you can write it down on your own. First understand and write it down on your own, whatever you understand. Model.invoke, you will get the outline, store your outline and update the state and return that state. Okay, so that will be the creation of the outline. Now the next stage is creation of the blog. So once you have the outline which is ready with you, now that outline will go to creation of blog function, because which is the flow of the graph. So in graph, now next is block state. Again, now this block state is having outline ready. So what you need to do? Take the title again, because again we need the title. This function also need the title. Then it needs the outline. So fetch the outline. Write down the prompt. Write a detailed blog on the title. Keep a placeholder, which is a title, using the following outline. Again, there is a placeholder for the outline. Simple F string notation. Prompt generation using F string notation. Okay. Invoke the model, update the state, whatever answer you will get, update that in your state having the variable called as content. This is my last variable, content. Okay. So now you return the state and you will get your answer ready. So now what you can do is you can just run this one by one. workflow will get compiled. You will get the graph, invoke the model, pass the input. It is fetching the answer for you. It will running the whole model. Model is formulating your answer, and it will give you the decent enough professional answer like this. Okay, right. You can just copy and then make a markdown cell and copy and paste and look at the whole content if you want. Okay, just create a markdown cell, copy this whole Control C, Control A, Control C, put it inside markdown cell and see what that output is. And if you want to see only outline, supposedly I don't want to see the final answer. I wanted to see only outline. So what you can do, you can directly, whatever is your final answer variable, from there you can just take down the state variable and print it. So that's how it gives you. Here is the detailed outline for a blog on the topic. This is the intro. This is the current state of the AI in India, government initiatives, and this is how it goes on. So now this kind of workflow is called as, which I explained you yesterday with N10, where I just drag and drop and write down some simple prompts inside each and every AI agent. Okay. Where I used some tool, but here I have not used tool. Tool I will explain you in very much of the detail. Okay. So why I'm using N10? This is the reason, because I wanted to give you the parallel idea so that you can visualize something on N10 and then you can implement this in the LangChain or LangGraph. Okay, right. So I hope that this thing is clear till now. Now let's add some kind of complexity into, let's go to the next workflow. Now next workflow is parallel workflow. Okay. Now how to uh, draw this, or how to invoke this kind of workflow. Okay. So the workflow is about calculation of some cricket scoring parameters. Okay. Like I want to calculate the batsman scoring rate with some parameter. Okay. So I am calculating strike rate of the batsman, boundaries per balls, number of the boundary percentage, and the summary. These are all are my outputs. So for this output, what I need, I need input as in runs. I need to know that how many runs the batsman has scored in an innings, how many balls he has faced, how many fours he hit, and how many sixes he has hit. Okay, so this is your state definition. You define the input, define the output. Do it like this only. Write down the comments. Uh, Input, write down the whole input. Output, write down the whole output. Okay. Now once you do this, what is the next step? Go to the graph. Form the graph. Now you understand the logic. For calculation of strike rate, calculation of boundary per balls, calculation of boundary percentage, calculation summary, do I need the sequence chaining? Like once I get the strike rate, then and only then I will be able to get the balls per boundary. Or once I have a balls per boundary, then and only then I will be able to get the boundary percentage. No, it is not like that. Once you have all these input variables ready with you, and if you know that this all four can go to the different functions and get the output for you, then you have to go for parallel workflow. Don't go for sequencing workflow. This is the logic which you have to think before you make a graph. Okay. So now you know that everything can go into this parallel. Like yesterday, I give you the YouTube example. Once you upload the YouTube, YouTube will check for community guidelines. It will check for content moderation. It can check for the adult contents. It can check for everything. Is it AI generated content or what? So that all things will can go in parallel. So that's why we are invoking the parallel workflow. Okay. Now see how to make a parallel workflow graph. You have a state graph, which is the batsman state. Now first it will go to calculation of strike rate. Like we are adding the nodes. What kind of nodes we need? How many outputs are there? Strike rate calculation, boundary per balls calculation, number of percentage of boundary calculation, and the last is summary. You have to add all these 4 nodes inside this your graph. Okay, so add all these nodes using graph.add node. Now, how to connect the edges? Now, see how to connect the edges. From start, one branch will go to calculate strike rate. From start, one branch will go to calculate BPB, which is boundary per balls. From start, one branch, the third branch will go to the calculation of boundary percentage. Okay, and from all these, it will go to the summary, because at last, whatever the output of these three will make one concrete summary. So summary will be the last node, and from where it will get the input, the summary, calculation of strike rate, calculation of BPB, calculation of boundary percentage, and from summary it will go to the end. Very simple way with which you can define the parallel graph. Now, once you have this, you know that what kind of functions you need to make. So you have to make this strike rate calculation, you have to make boundary per balls, you have to make boundary percentage. So now it will be much more clear that this is a first function. Okay. Now in this, I have not provided this return type like this one. Why? There is a reason behind it. When you look at this graph, every node will return the answer. Now there may be a problem. Whenever you return the whole state from any one of the node, when the other node will give you the answer, that may create the overwriting in the final state, which summary will get. Supposedly, I am getting the answer from calculate boundary. At the same time, this is also running, this is also running. But once this will update the state, since the states are mutable, it will update the state. It will give you the calculation of boundary percentage. That state will pass to the summary. Immediately at the same time, suppose this is also giving you the output. Now it is also having the state which is updated state. Now that can create the confusion with the summary node that may get overwritten. The state may have some kind of confliction. Same way at the third is also giving you the answer. So what you can do to avoid this state overlapping or overwriting or confusion, you can just return that individual values of the state. So I am returning from this only strike rate. This is a simple formula which I have used for calculating the strike rate. So I have written, instead of returning the entire state, only strike rate is sent, as it is calculated to avoid conflicts from the all parallel nodes. Very clear instructions or comments are written. Okay. I am not going into the detail. Again, you have to use state variables for getting the run state for getting the balls and apply the formula. This is simple. Same way, calculate the BPB, return only that BPB, because that is only updated in this function. Here only strike rate is updated. Okay. And then here only boundary percentages are updated. So return that only. Okay. Now these three functions are done. All these three function output will go to summary. Now again, it will get the state batsman state, where this state is having updated value of all the three result parameters. Okay, now what we are writing, just see to it. How LLM will give the summary, like strike rate, placeholder, balls per boundary, placeholder, like the value of BPB which it is being calculated from the individual function, boundary percentage we are deriving from the state. Because it is an updated state, we can directly derive those individual values and put it over here. That will be my summary. That's it. So this answer not LLM is not giving. This answer is simple, the user preferred answer. You can also use LLM to generate this kind of answer that write in the professional. But again, you have to give that prompt in F-string format or chat prompt template or prompt template. Okay. So you again have to generate the prompt, invoke the model, and then that summary In that summary, you just have to put these placeholders and write down some clear-cut instruction. I am giving you the summary of these three parameters. Write down and generate the answer in a decent professional manner. Yeah, this we can do, but currently just to show you, because this is the last node, so you can directly return the state from here. But what I am doing is, since I have taken individual, so I have taken here also individual. Okay. So once I run this, okay, I need to select the kernel. This is required every time. Your this package should be installed, and you will be running from this version only. So it will take a time because it is actually connecting to the kernel and activating this version of the kernel, IPython kernel. Okay. So it will give you the output. So if I give the, like, how to give the input: runs, balls, fours, and sixes. If you invoke that, what you are getting? You are getting strike rate, you are getting BPB. This is a summary. This is the boundary percentage, and that's what in all in one. Okay, right. So this is how you can make a parallel workflow. Okay, I am not running it. It is very self-explanatory that you will get the proper output. So I hope till now the things are going well. Yes or no? Yes. Okay. So now I will go to this workflow, which is UPSC. Like in UPSC, what is happening is that uh, there is some essay which the candidate has to write. Okay. So generally, the candidates are practicing for that essay, right? So this workflow is what? This workflow is like this. I'll directly show the graph. That I will start, and then there will be one essay which will be given in the input. That essay will be passed to all these three nodes. Now, what these three nodes are doing? One is, so now what you can do is you can consider this each thing as in one AI agent. This is AI agent itself, right? Ultimately, AI agent is also one function only, Python function, where we append the tool, we append the memory, and write down the functionality, what it has to do. But we have not implemented tool and memory. I will come to that in very much of the detail because I want to show you a React agent. Okay. So evaluate, that will evaluate the essay. Then one of the agent will evaluate the language of the essay. One of the agent will evaluate the thought process of the essay. And then all of them will give the answer to final evaluation, which is one more AI agent, and then that will be given as a part of answer. Okay, right? So see now, what will be your state? Now you should be very much uh, pro in this because you have seen many things now. 4 workflows you've already seen. So now the flow is very much clear that how what things comes first, what things come then second, and so on. Okay. So here I am creating one state, UPSC state, which inherit the type dict. Now what is my input? I will give the essay. Okay. What I wanted to get: language feedback from one AI agent, analysis feedback from one AI agent, clarity feedback from one AI agent, and the overall feedback from the final evaluator agent. And I wanted to score also. Okay. So means that this will give one score based on the evaluation. This will give one score based on the language of the essay. This will give one score based on the thought process which is involved in the essay. Okay, so all those scores are being merged over here in the final evaluation. And the final is that how much score you got from 100 or 10, whatever the number is, that does not matter over here. So that score we are also fetching it from the LLM. Okay. So for that, now that comes the new functionality. That is something called as whenever you want to uh, merge the things, like in this, I want to have a score from this, then score from this and score from this. That will get merged, and finally I will average those out and give you the final answer. I need to have all those three. So one by one, I should get the merging. Yesterday I explained you something called as reducers. If you have gone through my PPT, which is already being shared on the yesterday basis only. Okay. There was something called as reducer. Okay. So in reducer, how to implement that reducer? What was the job of reducer? To merge, not to replace, not to add, to merge. So here there is a reducer called as operator.add, which is again a line graph, very important component, reducer. How to implement the reducer? So here we are writing add is used as the reducer to merge individual list of scores. What it will be? This is kind of a list data type. So it will take the score from individual AI agent, put it inside list one by one. And the functionality which we are using is operator.add. And we have to write something called as annotated. Where this annotated is nothing but whenever we want to write some doc string, like I'll tell you in detail what is this annotated. You can just hover over to this and it will give you the idea that what this annotated is. Okay, I'll give you in detail why we write this annotated. Just for a time being, this is a kind of a metadata we want to include, like doc string. Right. Supposedly yesterday I told you sentiment positive or negative. So that is where I will write that return only positive or negative, that I am letting LLM to know. So for that the metadata is being attached with annotated. The simple keyword, that's it. And this will be a list of integer, list of a score. And this will be of average score, which is a average of all three. So now you have all the variables defined. Input is only one. Rest of them are all output. Okay, now make a graph. So how many nodes? Evaluation of language, analysis, thought, final evaluation. Nodes are being added. Start to first agent, start to second agent, start to third agent. Okay. Then adding the age from evaluate language, the score will get generated, score will go to final evaluation. Same from this, and the final evaluation, compile the graph. That's it. Okay, so we'll get something like this. Now you know that which kind of function I need to make. So I need to make all these functions. So let's go to this first, evaluation of language. Now how to, now this output will be given by whom? This output will be given by LLM only. Okay. So in this, what I will do is, first I need to generate the prompt. Okay. Now what kind of prompt I need to generate? So this is my first prompt. Evaluate the language quality. Again, input is what? The whole state itself. Evaluate the language quality of following essay and provide a feedback and assign a score out of 10. What it gets as an input? Essay. Where I have defined this is a placeholder. Where I have defined my input? I have defined my input over here. This is my input. India and AI time. This is the essay as an input which I have provided. Okay, right? So what it will do is it will take this essay and then it will invoke structured model. Now why structured model? Can anybody tell me? Structured model means what? I explained to you yesterday. Let's have some conversation, or like you can write it in the chat window. Why structured model? This is a structured model. LLM can only process structured inputs. Very good. For which what how many options you have? You have two options. First is with structured output. Second option is uh, output parsers. Output parsers. Okay. But many models are supporting with structured output, so you don't have to go to the output parsers. Okay, yeah, Jason. So here, what I want the score. Score is what? Score is only one number, means structured output. So what I want my model to get trained is trained on. I want my model to teach that please give me only score, and that score is only one number. That number when I will be able to get when my model is structured model. If I don't take it as a structured model, it will again give me the big bang text that the language of your essay is not proper or language of your essay is superb. It will give the text, but I don't want it to give the text. I want it to give only number. Okay, right? So for that, I will use with structured output. And how I will be able to get this structured model? I need to create one more class. What is that? Evaluation schema. Evaluation schema, which inherits something called as one more class of the structured output, which is called as Pydantic. So I will show you what is Pydantic. This is Pydantic. Okay. Now, what is Pydantic? It is again used for the structured output. Now, in typedict, what we are writing? In typedict, we were writing only typedict, the state class. The state class is typedict. But in Pydantic, we write base model. We write base model. Only for a timing you understand why these two. One for passing a state, we require typedict anyhow. Second is if you want your model to give only structured output, then you train your model with Pydantic. You teach your model what is Pydantic, because Pydantic is only also one way of getting the structured output, and that is very famous, more than a typedict. Okay. So how to write the Pydantic? Again, you have to create a class. Supposedly, this is a demo code snippet just to understand what is Pydantic. Class name is student, and the it inherits which model? Base model instead of typedict. Now, inside which you can write anything like whatever you want. Let's say name. Name is string. Age is, if you want to give age value in the input, then you give. Otherwise, you can keep it none. How? You can define it optional. Okay. If you write something like Nikunj at the rate adani.com or adani.org, this will also validate your email data type. This, what is the application of this? Application is what? Like, suppose if I give you the example that if you are a Adani employee or maybe employee of Reliance, and when you go to these giants, they actually have the option of, they have a tie-up with some hospitals like Zydus or Apollo, right? Now, whenever you are enrolled as the employee in Adani, then your name is there in the database of Adani, as well as they give your name to Apollo also. Let's say Adani is having tie-up with the Apollo. Now there are, let's say the first process is, let's say they ask you, the Adani group is asking you that go and get your blood test done because we want to have your report. That is the mandatory formal procedures to enroll as a proper employee of the Adani. Now when you go to the Apollo, your name and the email ID is already is there with the Apollo hospital. Then they will look at directly at the rate adani.com. And how they are able to do that? They are having this kind of Pydantic mechanism. Normal database, data structure, SQL, that is different thing. I am just explaining you the use case. Okay. So why it is more famous, Pydantic? It will validate your email with something called as email STR. It is inbuilt inside the Pydantic. There are many things which are inbuilt. Okay, you have to understand the use case first, that why we use this. Pydantic is used for that. Okay, so once you get at adani.com, it will try to match it with Pydantic. There is a mechanism in between, which is a Pydantic. It will match your ID with that, and then you are allowed to go inside and give your blood and come out. Maybe many schemes are being given by, like, Mediclaim schemes. Okay, so all these are tie-up schemes, or where you have to map the data, validate the output, validate the data. Validation of the data is always through Pydantic and uh, typedict. Pydantic is more famous than the typedict. Okay, so here I am just taking name as Nikunj, age as optional, email. I will validate my email also. Supposedly, if I write over here nikunj@.com, it will give you an error. The typedict, the Pydantic will give you an error. What it will ask you? You cannot write like this. You have to give the domain. You have to give the domain. You have to understand the use case. Okay, right? So that is how, see, it will give you. If you just hover over to this, it will give you what it is, right? And CGPA. Now in CGPA, you can just write down that greater than 0 and less than 10. And how you can define these kind of condition? Using something called as field. Right. So once you know Pydantic in detail, you will be able to know all these things. But I am giving you the brief idea that what is Pydantic and why we use it. Typedict, maybe some of the time it may not give you the error. It will take it as what you give. But Pydantic, what it will give you? It will give you an error. And sometimes it's like age is integer and string. Then it will automatically validate also. You don't have to explicitly typecast. It will directly validate. That is the feature of Pydantic. Pydantic is having very good functionality. It will be able to do it on its own. Wherever there is the self autonomy is required. Okay. So now if I give new student as age as 32, email as this student. So here I will get the structured output. So same way, if I want to get the score only, then I need to train my model with Pydantic class. And Pydantic is nothing but base model. Now see what I'm writing inside this evaluation schema class. I want two things, feedback and score. Feedback is a type of string and score is type of integer. What I will write now, this is why we need field. You can attach metadata. If you write this, LLM will be able to know more. Like if I write detailed feedback for the essay, LLM will be able to know more about your this variable, what is feedback, what I need to do. Okay. Same way, if you write the score, then there is a description is written. Score out of 10, you have to give score out of 10. Make sure it should be greater than 0, greater than or equal to 0, and less than or equal to 10. Less than or equal to 10. This condition you can write it over here like I have written over here. CGPA. Okay, right. So same thing I have used it over here. So field is used to let prompt, you see, prompt generation is not there. This is, we are training the model with the structured output. Okay, please, I'll just explain first the whole flow and then again I will revise. Okay, so detailed feedback for the essay and score. So this is my one more class which I have created. This is inheriting Pydantic. Now this class I will pass to the with structure output because my grok is supporting with structure output. My grok is supporting with structure output. So I will make my model learn about what is this evaluation schema. इसको सीखो कि evaluation schema क्या है. Model को ये I need to convey. Okay. Model will go, it will learn. Feedback में क्या करना है? Detailed feedback for the essay. What I need to do? I need to give a detailed feedback. What is the type of that? String. Then score. score में क्या करना है? I need to give a number. What is the range? Greater than or equal to, less than equal to. That's it. You have to make your model learn. And for that, you have to make this kind of classes, which gives you the structured output, which inherits Pydantic or typedict. Okay, right? So now I will come back to this evaluation of the language. Now my model is structured model. It's not its individual model because I have trained it over here. See this. My model has learned evaluation schema. He knows that now I need to deal with only feedback and score. That's it. I don't need to spit out anything else. Okay, I need to just give the answer of feedback and score. Okay, so now it will evaluate the language. You invoke the model, give the prompt like this. Prompt is given for this only. You cannot prompt is to ask the question, not to train the model. We are training the model with the data and what kind of output we want. We are training the model with Pydantic and typedict. We cannot train the model with prompt. Prompt is just a way of asking the question. Okay. So evaluate the language quality of the essay, and this is the placeholder essay. I will invoke the prompt and it will give me the output. Same way I will do it for evaluation of the analysis. Same structured model because it is also going to give me the score and feedback. See what is the output, what it is returning. Language feedback and language score, individual score. Okay, right? It is also feedback and score. It is also feedback and score. Right? You just have to give the prompt to all these three and then final evaluation. So what is the final evaluation? One prompt, one more prompt. Based on the following feedbacks, create a summarized feedback, language feedback, which is you have to take the value from the state of this variable. Detailed analysis feedback, you have to get the answer from this state of the variable. And clarity of thought, you have to get it from this variable. Then overall feedback, combine them, make your overall feedback, and you can also calculate the average score. So you have the overall feedback like based on this is the answer and the score, average score. Okay. So this is your this UPSC workflow. Okay. So there are few more things which is being added in this, which are for those whenever you want your model to learn structured output, use Pydantic and state always typedict. Keep this in mind. This is a very short trick you have to remember. Okay, and your model is not able to understand this method, which is with structured output. Then you have to go for something called as output parser. That code also I have kept it over here for you. So whenever you get the time, or maybe I will get somewhere in the Pydantic output parser where I'm using, I'll explain to you this. But you can go through this from this. Okay. Then next now, so parallel workflows are over. Now let's go to the conditional workflows. Right. Now what are the conditional workflows? Now here I have taken, again, there is no LLM involved in this. So what is my ultimate objective? Calculation of discriminant. Calculation of discriminant and then decide the three condition which we know. Minus b by 2a real and repeated roots, right? We know minus b plus or minus under 4ac by 2a. That's how we calculate. Then there are three conditions: real and repeated roots, no real roots, and then plus or minus two different roots, distinct roots. Okay. So that is the objective. Okay. So now what I need to do is I need to define the state. What is the state? This is the name of the state. How many values I need to give? A, B, C, because I need these three values to calculate the discriminant. Now, once I am having the discriminant, then I can go for checking of the condition. Which of the condition is getting triggered? From those three, right? That is coming under the umbrella of conditional workflow. Okay, again, no LLM is involved. I will give you the next point where next task, next code where LLM is involved. So uh, these are your three inputs. These are your two outputs. Now go and make a graph. So what will be your logic? First is calculation of the discriminant. So that will be your first node. Now, how many possibilities are there? Three. Either it is having real roots, either it is having repeated roots, or it is having no real roots. Right? So you have to add all these nodes. Right? Now see the main new part, which is how the edges are being added. First is start to calculate the discriminant. Next. Now next is when you calculate the discriminant, you have three options: 1, 2, 3. And these three are conditional edges, not the solid edges, or maybe the flow is not dedicatedly directed to that particular node. The flow is based on condition redirection, right? So for that we have something called as add conditional edges, right? And in add conditional edges, we are adding something called as check condition. From where it will start? Calculate discriminant. From where it will start? Now here we need to add check the condition. That is why I am writing check condition. Now what is this check condition? There is one more function which will check the condition. Okay, right. So this will be one more function which will check the condition based on the answer of the discriminant which you are getting. So for that you have to write down the logic, check condition function. Okay, right. Now after that, whatsoever path will get selected, let's say the path selected is real roots. So your flow will get diverted from this calculate discriminant to real roots to end. These two will not get triggered. So now if you see, once the conditionals are checked, from that you just have to write real roots to end, which is the first possibility, no real roots to end, and repeated roots to end. It will automatically take whatsoever path will get triggered, that workflow will get actuated, and it will give you till the end path. So this conditional edges are also one kind of, you have to write one function. There also you have to write one. This is a new extra one functionality which is added in this workflow because it is a conditional workflow. Okay, right. So now you know how many functions you need to write. Calculate discriminant, real roots, repeated roots, no real roots, and check the condition. Okay, right. So now let's go to the function one by one. First is calculate the discriminant. The first value, first state, obvious state, which is by default state, which has to be implemented first. We are having ABC, apply the formula, return only the discriminant. Not the entire state, only the discriminant. Now you can just trial and give the trial and error. What will happen if I just return the whole state? If I return the whole state, what will happen? Just check it out from your end. That's how you will be able to learn. Okay. Then once you calculate the discriminant, what is the next step? Check condition. So it will go to the check condition directly. Here it will take the state, okay, and from that it will apply this logic. If state discriminant is greater than 0, equal to 0, or the last condition is less than 0. These three are written in if, elif, and else. Now what you want to return from this function? You want to return either real roots, repeated roots, and no real roots. For that you have to write like this. The output of this check condition will be any one of these three literals. Literal means any one of the given entities in the list. Either it will be this, you have to define it like a literal. Either it will be this or it will be this. Any one of things, this function will get returned. So supposedly, if discriminant is greater than 0, then the output of this function will return real roots. This too will not get triggered. Now, once this will return this, what will happen next? This function will get called. What is that function? Real roots. What is written inside real roots? We have to calculate the real roots. What are those? Minus b by 2 plus or minus b, the whole formula, by 2a, right? Minus b plus minus b minus b plus or minus 2a, right? Minus b divided by 2a, and whatever the formula is. Okay, the discriminant into 0.5 minus b plus or minus plus delta 0.5 divided by 2a minus b minus delta into 0.5 divided by 2a. It will calculate this root 1 and root 2 and return the result. Supposedly, if this is returning repeated roots, then it will go to repeated roots and it will calculate minus b by 2a and it will return the result. If it is no real root condition, then it will directly write no real roots and this will return this answer. So why we are taking same variable? Because any one of the branch will get triggered, not all the branches. Okay, right? So if I give the value a4, b5, c minus 4, if I invoke this is what I'm getting. Okay, this is discriminant greater than 0, so roots are this and this. So this is conditional without LLM. Now with LLM, what is my task over here? Okay, we can take this in the next session. I don't want to bombard since we have only 5 minutes or 3 minutes, sorry. So you can, if you have any question, you can tell me. Yeah, any question? So anyone has implemented at least one code which I have given you? Okay, first one. So is it going good? The pace is fine, or I should increase the pace? Obviously, now you are knowing about flow, so I can increase somewhat. Yeah, thank you. Subhasri madam. Abhi now, yes, good, thank you. This is fine. Yeah, don't run it now because it will be then very confusing. And again, the codes are working fine, you just have to run. So if you get any installation error, you can get it done from the ChatGPT or whatever model you use. Any installation errors are there, you can just solve it from that model because those are available with you. So you can just copy and paste errors, or maybe if you use GitHub Copilot or Cloud Code in your VS Code, then that will get solved. Okay, yeah. So I hope we are good. We are going good, and hmm, Okay, so we can then conclude this session. We should have idea of OOPS or writing code. I am not from CSA background. Shilpa madam, you can uh, start visiting the, like if you know Python and if you don't know OOPS, then directly you can jump to OOPS concept. OOPS concepts are you have to practice that what how to define the class, how to inherit that class, how to make an object of that class, how to use the functionality of methods in this class. Anuj, this is orchestrator only. We are defining the flow. Flow means orchestration. We are then we will put the master agent inside this. That will come in agentic RAG. This is orchestration only. Orchestration work, the main, if you are talking about supervisor agent, that we will be adding it in the next part. Don't rush to the concepts. Yeah, that will come later. Once you have tools with you, once you have memory with you, then that will come. Okay, so don't rush to the concepts. Understand this flow. This is the flow, exact flow which with which I understood and I am able to code from my side. Okay, so don't rush to that is what is the lack that everybody wants to get into directly making the AI agents, right? Nobody wants to go for the foundation part. Foundation should be much more clear from the documentation of the library, right? If your foundations are strong, even if you wipe code, then also you will be able to generate all these things in a sequence like data ingestion, model training, model testing, Dockers, APIs, wrappers, cloud, Kubernetes, all these things will you be able to do it in a sequence. Okay. So don't rush to the advanced concept. When you get something like that without coding, you can achieve using no code tools. No, that is totally, from my POV, that is totally wrong. Even in NA10, you have to code somewhat. Okay. So without coding, there is no things are possible. You should know the foundation of coding. You should know the foundation of Python. If you don't know Python, these are the sessions side by side you can learn the Python so that you can get the exact idea, map it with the sessions which are going on. Okay. Yeah. So I hope this is okay. So moderators can now take over the control and yeah.
Yes, thank you, sir. Thank you for this wonderful session. If any participant have any question, they can raise your hands. Otherwise, we will wait for 2 minutes and start our new session. Thank you, sir. I don't think they have any question. Okay. So for next session, we have Dr. Mahipal Jadeja. We will wait for just 2 minutes and start his session.
Sure, sure. Just give me 2 minutes. Yeah. Okay.
Okay. Thank you.
Thank you.
Thank
Thank
you.
you, Nikun sir.
Thank you, sir. Thank you. Thank you all.